All right, we are continuing. Here is the more complicated model. Hopefully you can hear me and see everything. So here's the more complicated model, and here is the construction which we are trying to place inside the model part. So the model part has the logic. This is not the plus sign. So we do not add L caret and color. We place the separation mark. So plus makes the separation. We need to place the model which tries to predict the logarithm of price based on several other variables, which are the logarithm of caret, which is color, cut, and clarity. And we need to predict our model based on these four variables. So we just separate them with plus signs. There are also different kind of signs which can be like the multiplication. So it will try to get the plus sign, so add the single variable and add the interaction term between the L caret and color. But this is kind of more complicated, and for now we just need to use four separate variables inside our model. We will call this model diamond 2. And here it is. Let me close that. And we can see our model diamond 2. It also has the coefficients, and as you can see, there are 19 coefficients. Why that? Because we have a combination of numerical and qualitative factors. So clarity is the qualitative factor. 1, 2, 3, 4, 5, 6, 7, 8 types of clarity. There is the cut, which is also like that. This is color, and the cut 3, 4, 5, and all together we have the 19 factors altogether. So here are the coefficients, or maybe we just take a look at our model. Let's have a look at our model diamond 2. So here we have the coefficients in front of our variables, the intercept, the caret, the numerical variable, and color. They are depending on our color LQC, 4, 5, 6 other types. Cut is 4 types, and the rest is clarity. So here is our model, and there are positive and negative coefficients. So the color of L lowers the price, the color of Q lowers the price, but the color of other type besides seal it open. Besides maybe 1, 2, 3, 1, 2, 3. The G, F, E, okay, or maybe D, E, F. We need to further explore which types of variable, because it creates automatically. We haven't named them, but I think that the color J should be selected as the preliminary variable, which is not included here. And here are the variables which are calculated based on the IHJ and so on. So the naming of these factors is automatic, and it does not correspond to the regular factors. We need to rename them, and in econometrics I'll show you how to do that to get the summary results according to the data set itself. But for us, we don't care. We just can explore that this model is quite more complicated. And using this kind of model, we will modify the grid. So this variable grid was calculated based on 20 observations of the price and carrots. And we again will use the our model, which is the link to our model diamond 2. And we add predictions based on cut. So previously, we made predictions here to the variable grid based on carrots, right? Model diamond based on carrots, because we have only single value, a single value inside, single variable. But here we are going to use the cut as our main factor. So here we are, our grid value variable modified, and we can see that the, we also can see this here, the view of grid. So our carrots is the same. We just care about the cut, which is fair, good, and so on. And here are the predicted prices. Again, we need to take 2 to the power of this to get the idea of how much each diamond costs. So let's plot that, and we can see this relationship, which is non-linear. Actually, this is again logarithmic relationship, and let's use the residuals again. We are producing the same kind of result, but using the different model. So we will use the LRZ2 because we already have the LRZ from our first model. We will name it as LRZ2, and here is. Here are our residuals from the second model, and again we try to get the understanding of what is happening. So whether this model works better or not. As we can see, the model works much better because the difference between the residuals is tighter than in the previous model. And again, our major points are situated on the 0 value of residuals. And we can see that our smaller diamonds are not very good predicted. Some of them have the outliers. And the majority lies in this kind of the rectangular. And all in all, this model is much better than the previous one, just based on the observations. Of course, we assess the quality of our model not based on our like the view of the residuals, but this kind of view is giving us a lot of information, very useful information to assess. How to assess the model? There are special metrics besides that, and the prediction quality, and of course after RMSE the basic metric there is the separation to the training, validation, testing data set, and checking how the model performs there, and calculating the loss on these metrics, and there might be different one. Don't worry about that, everything is really easy because there is the single line of code to make that. So what have we done? We already got our grid value, and grid value just places some points. In this particular case, it places 5 points, as we can see. 1, 2, 3, 4, 5 points based on each kind of cut we have. And based on that, we calculate the residuals between the point. So we calculate the residual. Let's say that the cut is very good, and maybe the cut is very good, and here at 11 something, maybe between 35 and 40, let's say 11.37, and we are calculating the residual based on the difference between this price, this point, and the others. So all the diamonds which are having this kind of cut, we calculate the residuals, and the residuals, they are tighter, and this is really great. All right, what is going on here? We are going to find out what are the residuals, what are the outliers. So here is the value of 1, and here are several points which lies up the 1 standard deviation of the residual. And we filter those which are larger than 1, and we filter those which are lower than -1, right? And we placed these kind of points and these kind of points to predict to our model to predict what are the prices, and we arrange the price from where is the price from lower to higher value. So we got the table which has 16 observations over here, and we can look at those residuals. Maybe we can find something, but for me it's okay. These are not some strange diamonds. It's believable that the premium cut and slightly colorful, or maybe it's not very colorful. D and D, very good category, but with slight inclusions, it may cost that much because it's fairly large diamond. So it's a good practice to build our model, build this kind of plot, and separate the residuals. Separate the residuals which are very largely different from the majority of the residuals, and then explore the data set that we obtained from that. Very good practice, especially if you are involved in some kind of medical data. These kind of residuals might be something special, and scientists might discover something unusual, and maybe discover the medicine which works for this kind of people, because they are very different from the majority of the group. So here are the diamonds which are quite different. Why are they pricing those much, and why the premium cut and very okay diamond, but with slight inclusions, why is it costing this much, not lower, or maybe not higher in this particular case? Okay, so this is the ways how we interact with our data, how can we build model and check the residuals. So please pay attention on the mutate. Mutate creates the variable, and here we automatically change the perception, because our model was logarithms, and we change the perception of converting back to the linearity by 2 to the power of. This is true only with our log2. We have we have log2. Okay, if we have a different, like log10, then we will use 10 to the power of, and if we use the regular log without any twos, without any tens, just regular log, that means we will need to use the exponenta to convert back to the normal. So if we have been using log, then we will use the exponent to the power of. Okay. Next thing is what affects the number of daily flights. So we won't have much time to explore, but still, let's start with the first perception. We are trying to form the yearly observations, and here are the yearly observations, the date from 2013 to the ending 31st of December, and here is just the count of flights. So we calculated how many flights we had during the whole year. So these are the daily, the extract from the New York flights data set, which contains much more data than that. So using this daily, we are going to plot what we obtained, and here is the number of points which are connected with the line, because we use geom line to represent the data. And here we can see that at some particular points there are very low flights, and near that there are higher peaks and so on. So our first impression that the number of flights depend on the day of the week. So we might use the day of the week as our variable to predict something. And yes, we are doing this. Here is our data, our two variables, data and we create the weekday based on the label of our data, W day. Okay, so here's the W day. It's using the Lubridate package automatically. Once we load the dplyr, it uses the Lubridate package, and here's the variable W day, and it automatically calculates which weekday it was. Okay, so we are using the W day, the ordered factor. We consider the Tuesday, Wednesday, and so on automatically. And based on that, here's the single line which uses this weekday and creates the geom box plot. So here is our box plot of when we consider the Saturday really different from the other days, and we can explain that because the majority of flights to New York are business trips, and the business trips actually they are on business days from Monday to Friday. And Sunday is going up because lots of flights starting from Sunday and they arrive to New York on Monday morning. So that's why the Sunday flights are also kind of high. But Saturday flights, they are neglectable. They are much lower. Lots of business trips are lower than in a regular day. So this is kind of reasonable. And again, here is our model. We again try to perform the dependency from our how many flights we have based on the weekday. Okay, so here is our model. Our model has the coefficients. It has 7 coefficients based on those values from Sunday to Saturday. But again, as you can see that there are one less, always one less. We can have 7 days a week and we can have 7 coefficients, but the first coefficient is the intercept. So our mod coefficients, we can see that here's the intercept, and here are our 6 days inside the week, because if we don't have any weekday, if we place 0 there, the intercept will be represented the coefficient of the 7th day. We always must do the same. If we create the variable by ourselves, we also have to use the n-1 factors, because it will be really explicit to use the whole factors and the model will be wrong. So automatically creation is okay, and we can see that these are the weekdays from Sunday to Friday, let's say, or maybe from Monday to Saturday. It depends on the model. We have to, we'll get back to that next semester. Again, as in our previous versions, we're using this daily data set, and we create the data grid weekday and adding the predictions from our model. So here is our grid. It uses the weekday, and here are the predictions. And we can see that the Saturday prediction 744 much lower than the rest. Next, we are going to plot what we got. And here are the red dots. Of course, we can modify the color and the size, but we're using the data from this small table, only these 7 observations from this table, and place these dots, which represents the mean values, the average values. And you can see that the average values are slightly lower than the median values, which represent the bold lines inside the box plots. For Saturday, it's okay. For the rest, the average flights is not very greatly stands. So there are skewed distributions on each of the day. Let's visualize the residuals. So we are producing the same kind of thing that we have done for diamonds, just for using the different data set. So for you to understand the whole process better. And here are the residuals, and we can see that there are significant differences in some particular dates, like July, and you can see maybe there is something in July, maybe there is some holiday in July here, and maybe there is some holiday over here. And so of course, we can see that there is a Christmas and the New Year, where the flights are much lower. So you can extract those days as the holidays inside, and you can see that the significant differences between the number of flights, and slightly after that, we can see the peak, much higher flights on that day. Maybe people are trying to get to their friends or relatives and so on. So here are the visualization of the residuals. I think I should continue without the break because we have to end up in this recording. So here is the here are some notes. You can read that later on. So hold on. Daily geom line. This is this graph. Okay, and here we try to model that with different color, and here each different color represents the quantities of flights based on the days of the week, and we can see significant differences. So day of the week really is important for predicting our values here. So we just provided our weekday is the qualitative variable, which has several layers, several factors, and we based our coloring based on that. So here are the factors, here are the colors, here are the 7 lines we got. So on Saturday, our model fails to predict, and there is a significant difference. For the summertime, we have 3 down peaks there. So let's filter those values which are lower than 100. So here is our threshold value, minus 100. So residuals which are lower than minus 100 will be extracted from our daily values. And we can see 11 observations over here. The New Year, we can see some kind of these values from the Independence Day, or what's it called? The Christmas, we can see others, and we can see some kind of other holidays on the November 28, 29. So these are specifics for United States, for New York. For Taiwan, it will be different specifics based on your Dragon Boat Festival and some other types of holidays, national holidays. So number of flights will be dependent on those. And it will be easily seen with the simple model, just how many flights there are based on the weekday. This was our simple model. Where it was. Here it was, based on this model and based on the residuals, which is automatically generated with our model. Here are the residuals, dollar residuals. Okay. After that, after we filter those residuals, we are going to color. Yeah, we are going to provide the smoothing regression, the smoothing spline, I would say. This smoothing spline is the blue value, and it tries to get rid of the big fluctuations. So the smooth line is like that, and we can see the on average how many flights they are, and we can see that the people are preferring to fly it in summer, and these peaks are very constant, very greatly depend on the holidays, like the uh, students' holidays, and people are preferring to travel a lot in summer. And of course, there are not very much travel in January and in winter. That's reasonable. Students are at schools and parents are at work, and everything like normal, low number of flights. So let's explore this seasonal Saturday effect. We are going to filter the Saturdays only from the daily flights, and we place how to say labels as these dots over here, and we can see how many Saturdays we had. Maybe 52 weeks, so we got something like 52 points here. And okay, we can clearly see the change in how many flights there are on Saturdays only, and not much in autumn, and a lot in uh, in summer. Okay, so next, what we are going to use here was the table. Here was the table with specific dates, and we're going to use those specific dates, these four holidays, and we're going to use the term to get those dates inside. And then we are going to add this term inside our daily and produce the same kind of graph, but with this term. Okay, here is the term, and here is the how to say, the graph which separates three seasons like spring, summer, and fall. Okay, so here is here what we used 0605 the spring, the frontier, and here's the summer frontier, 25th of August. Really strange. I was thinking about the Labor Day in September, but okay. And the January. Okay, so we have separated. Here are our three seasons. And let's have a look of what we have based on our seasons. And we can see there is a significant variation across the terms, and Saturdays, depending on it doesn't matter which season we are talking about, the Saturday flights are much lower to New York despite the season. And we can see that the variation of spring flights is the major. So it's really hard to predict for us for springs. And the least variation is summer. And we can see that the whole lots of people travel in summer. And so it's easier for companies to arrange flights because there are like lots of full planes are flying. The same applies to fall, but it's really hard to plan for spring because the variation, the number of people is large, and there are half full planes, or maybe less planes should fly during this season. So really good insight for company managers. Next, we're going to build two models. Model one is the same kind of model which we already built. Number of flights depends on the weekday. And here is the weekday times term. So here's the interaction between the weekday and the term. And we're going to use those two residuals of those model. And the first residual will be without term, which is the same kind of line which we already got from our basic model. And with the term, we can see the really smaller variation, and we do not have those down peaks. And we can place the predictions of the number of flights based on our, make it larger. We can make the predictions and we can place those prediction points based on our data. And we can see that the predictions are not good for our fall and summer, but they are okay for spring. This is not good because summer and fall are higher seasons and spring is not high seasons, not high season. Okay, so we have produced this kind of plot. So our model is finding the mean effect, but we have got a lot of big outliers. So we can see that the difference is significant. We have outliers during the fall a lot. And let's make it spline-like way. Is it okay or not? So RLM is the robust, robust means stable linear model. This is another way of trying to make the predictions more stable through those outliers. A good way of modeling just using the mass package RLM. You can read this RLM just placing the F1, so robust fitting of linear models, what they are doing there. And here are some links to the algorithms that they applied. All right, so what we can see here in the plot, we can see that a lot more points are lying on the zero value line. And of course, there are several points because we haven't used the deletion of those outliers, but the long-term trend with positive and negative outliers is much easier to see on this kind of graph. All right, so here I would say that here is enough for us to get, but we only have three functions, which is involved the computation of variables. So just have a quick look what we are doing, what we're doing here. It's a good idea to bundle the creation of variables inside the function. So here is the compute variables, which is the function, which we already know how to create based on our first part of the course. And we are inputting data inside the function, and this data is being mutated inside the function. And because we are not returning anything, then the last line of code will be returned. So it's not necessary for us to place the return data. Data will be returned automatically. So we place data and we return data, which is placed in the compute variables variable, okay, compute vars variable. This is the way how we should use. So I recommend you use this way because it's more like the traditional programming languages like Python and others. You create the function and you implement the function. Here's the possible way, but I am not recommending you to use this way because it's really hard to understand that this is the function itself. WD is the function itself, and we're using the function itself inside the linear model, and this is not straightforward. But this is okay for R, and for if you are going to use only R in your whole life, of course you can do that. But regular programmers will be much grateful if you are going to use the separate functions so they can understand what's going on there. All right. So here is the compute vars, and you can use these compute vars to just mutate, create the term from the date, and use the W date as the label. Okay. Time of the year alternative approach is not necessary, but still it's possible. So we are going to use the only working days, 5 days inside. And here's the another possible way of creating the daily variable, separating it to several lines, and I'm not seeing labels here, but there should be the same kind of labels, and we consider Saturday is really diverse, and it's easy for us uh, to implement the prediction on the rest. Okay, so hopefully, yes, it's a lot of things which were happened. This is because we need to place only one week for the modeling, but still there are two big examples. The pattern of what you have to do is pretty straightforward. It doesn't depend on the tasks. Tasks are okay, like I would say. If you experience any problems, that's normal. Before exam, I'll explain how to do that, and if you got some hard some difficulties in dealing with the tasks, I won't downgrade. So don't worry about your grade. So the whole situation here is that once again we are returning to our diamonds. The whole situation is that you have to understand what is your data, and just based on the exploratory data analysis, sometimes you might get opposite or non-logic way of filling of your data, and instead of just uh, placing like maybe there is something wrong with the data and there is something wrong on the data collecting part. Maybe there is something wrong with the way that you're trying to look at your data, and maybe you have to model first and use the residuals from your simple linear models to get the another way of looking at your data, other big residuals or not very big residuals, and use those to predict, to understand what's happening there. So all in all, hopefully you won't be terrified with the overwhelming information you received, but still it's really great for you if you understand what was going on, and if you uh, if you will be able to repeat that. Of course, you have to use you need to use. It will be really beneficial if you get the idea of ggplot and how you can present your data beautifully, and then in your courseworks and maybe in your competitions, you will use these beautiful styled graphs and use the modeling, and everything is everything will look really nice in the terms of the judges' eyes, and anything which tries to see those beautiful pictures and believe that actually you have done it, and that will be beneficial. You will be able to earn money with that. Okay, what else? I'll think about what we are going to do next couple of weeks. So now it's week 14. Week 15 and week 16, we have to maybe if everything will work fine, then we'll try uh, to build our application